Good morning, students. Myself is Mrs. S. Sangeeta, working as an assistant professor in Kongonadu College of Engineering and Technology in the Department of Information Technology. So, in this class, we are going to see the subject cloud computing. So, in cloud computing, we are going to see Unit 5. In Unit 5, the first topic is called Hadoop. So in this class, we are going to see the every details regarding Hadoop. So the Apache Hadoop is an open source software framework, which is mainly used for data processing applications, which are executed in distributed computing environment. So the applications built using Hadoop are run on large data sets distributed across clusters of commodity of computers. The commodity computers are mainly useful for achieving greater computational power at low cost. The data residing in local file system of personal computer system in Hadoop data resides in a distributed file system, which is called a Hadoop distributed file system. So actually, the Apache Hadoop is a collection of open source software utility that facilitates using a network of many computers. The computers are connected through network to solve the problems involving massive amount of data and computation. So Apache Hadoop consists of two sub-projects called Hadoop MapReduce and then HDFS, that is Hadoop Distributed File System. So MapReduce is a computational model and software framework for writing applications which are run on Hadoop. It is a software framework for easily writing applications which process vast amount of data in parallel on large clusters of commodity hardware in a reliable, fast, tolerant manner. These MapReduce programs are capable of processing enormous data in parallel on large clusters of computation nodes. So the next one is HDFS. HDFS takes care of the storage part of Hadoop applications. So it is completely handling the storage part. That is, it employs a name node, data node architecture to implement a distributed file system. The MapReduce applications consume data from HDFS. The HDFS creates multiple replicas of data blocks and distributes them on compute nodes in a cluster. We will see all the details with appropriate diagrams in the forthcoming slides. So here we are going to see about a data node and name node. So here name node, we will have only one name node in the entire HDFS architecture, and we are going to have more number of data nodes in HDFS. So the data nodes actually store the data, that is data blocks. The name node stores the metadata information. Data node and name node. HDFS has a master slave architecture only. The name node is acting like a master server which manages the file system namespace. And then there are a number of data nodes. They manage storage attached to the nodes that they run on. Okay, the single name node is handling more number of data nodes. The data nodes are only going to store the client's data, and the name node is going to store uh, the data where the original data is stored in the various data nodes. That is, in which locations of which data nodes the particular block is getting stored, what is about the replication of data. So all kind of informations are stored in name node. So internally, a file is split into more number of blocks, and the blocks are getting stored in data nodes. Okay. And then the name node executes file system namespace operations like opening, closing, renaming. So these operations are performed by name node. And then the name node determines the mapping of blocks to data node. That is, it will check which data node is free at that moment. And for that data node, the maps will be allocated and the mapping information will be maintained by name node. And then the data nodes are responsible for serving read and write requests. And then they create the data nodes also perform block creation, deletion, and replication upon instruction from the name node. So these are the functions of name node mentioned clearly. So it's a master daemon, and then the slaves are data nodes, and it records. Already we saw the crispier one. Here we are seeing in detail. So it records name node, records the metadata about the files stored in the cluster, and then it stores the information like location of blocks stored and the size of the file permissions and which kind of hierarchy followed. So like that, all the informations will be stored in name node. And there are two files will be associated with the metadata like fs image and edit logs. Fs image, it's the complete state of the file system namespace from the start of the name node. And then edit logs, it stores the recent modification logs. Okay. And it records with recent fs image. And here the name node receives the heartbeat and a block report from all data nodes. Heartbeat is nothing but periodically it will update what informations are stored in data node. That is, everything will be updated periodically, and it keeps record of all the blocks in HDFS. And here we are having one term called a replication factor. So it is nothing but if we have one block of data, how many times it is replicated among the data nodes. That is called a replication factor. In case of data node failure, the name node will choose the new data node for new replica. For example, one particular block in data node 1 is getting failed. That is, the data node 1 is getting failed means automatically the name node will receive the data from its metadata, that is in which another data node is having the same blocks replica. So likewise, it is easier for data reforming. So data node, actually it's a slave node. Here they are running on each machine. Actual data is stored in data nodes. The data nodes perform the low level read and write requests from the file system's clients. They send heartbeats to the name node periodically to report the overall health of HDFS. By default, this frequency is set to 3 seconds. So secondary name node, it's a third part of HDFS. It's a helper daemon. That is, the secondary name node will work concurrently with the primary name node, and then it will be having the backup of name node. That's all. The file system namespace. So the HDFS is mainly following the hierarchical file system organization. So the user can create multiple directories and they can store files in the directories. And the namespace is providing the to find the file or appropriately. And then one can create and remove files, move file from one directory to another, or rename a file. Okay, students, now I think you are all clear about Hadoop file system. Thank you for your patient listening. So in the next class, we will see about MapReduce concept. Thank you so much.